Hi everyone, welcome back to the channel. Today we are going to discuss about 4 variable Karnaugh map, K-map. So in the previous video we are already discussed about 2 variable and 3 variable K-map. So if you don't know about those two things, I am giving the video in the description box. Check it out. So in this video we are going to solve many logical simplifications using 16 cell or 4 variable K-map. So let's get started. So this is the overview. So let's see that for n variables we have 2 power n boxes or cells we can call them. So these are the 2 variable and 3 variable we have already discussed in the previous video. In this video we are going to see just the 4 variable K-maps and its application. So where we are going to use and so many logics based on 16 cell K-map. So let's get started. This is the overview of 2 variable and 3 variables like K-maps. So let's also see the 4 variable K-map, how it look like. As we aware, this is 4 variables. So A, B, C and D is involving here. So we have to consider that these 2 power 4, 14 cells or 14 boxes we can call. In the digital electronics we call them cells. So let's see how it 4 represented the 16 cell. So as you are seeing there, we have to represent 4 cross 4 type boxes. So that is known as cell. Each one box is known as cell, that is 16 cell K-map. In each box I represented separately that individual corresponding A, B, C, D inside. So you in that is binary. You can convert into normal decimal and you can write in the boxes as well. The top one, that is 0, 0, 0, 1, 1, 1 and 1, 0, that is known as gray code. So bottom also for AB and CD. So if you take AB, that is row wise, and CD, that is column wise, if you observe clearly. So that is known as gray code. If you don't know about gray code, I am giving that video also in the description box, check it out. So basically gray code means a single bit change or unit change. So if you take any of the two side by side, that is only will be changed in single digit. So that is known as gray code. So this is the thing that I am saying about. So the inside thing that we are representing as a decimal. So from binary to decimal we have to convert. We also know the binary to decimal conversion. So after converting, the table will look like this. So it is not like normal thing going from 0 to 15. So it is generally a random way. So you can remember this table like, so start with 0, 1. So skip 1, 2, come back 3. So again you are going to start with 4 because you have completed up to 3. So 4, 5. So next you are going to skip 1, 6, come back 7. So skip there a row. So 8, 9, skip 1 box, 10, come back 11. So then last and final one, that is third row. So 12, 13 and 14, come back 15. So this is the 0 to 15. So this is the thing that you have to remember. So because from 0 to 15, that is 16s. So we have 16 cells total. So these are known as SOP formats also, we can call them simply. Gray code correspondingly we can convert 0, 0, 0, 1 that to C and D and A and B as well in the format of variables. So if you observe C bar, D bar, that is in first of all it is 0, 0. So we can write that is C bar, D bar. If 0 is there, that is bar variable, that is variable bar. If 1 is there, that is variable only. So this is the format of writing in as well SOP format. So we are writing in SOP format. So that is C bar, D bar, C bar, D, C, D, C, D bar, as that is going from columns. If you see row wise, that is A bar, B bar, A bar, B, A, B, A, B bar. So this is the thing that we can represent like this also. Before going ahead, so let's see an example why we have to use the K-map. So we have already discussed in 2 variable, 3 variable, but it is very important to discuss in this video also with the help of 4 variable K-map. So let's see, they have given 0, 1, 3, 4, 8, 13, 15. So that is known as SOP, that is known as sum of product terms. So if you observe that 0 can be represented as 0, 0, 0, 0. So that is A bar, B bar, C bar, D bar. So 1 can be represented as 0, 0, 0, 1. So that is A bar, B bar, C bar, D. So likewise you can represent all the things. So you can observe these are many more terms, like 1, 2, 3, 4, 5, 6, 7 terms. So total 7 terms can be represented like this. By using K-map you can simplify this to these 4 terms. So see, the 7 terms has been converted with the help of K-map, as simple as that. That is with the 4 terms. So we can also minimize the expression, the 7 terms expression, with the help of Boolean algebra also. By taking A bars command and doing some algebraic Boolean algebra, we can also do that. But by using K-map, we can have many more variables. We can do very simple. We can have 2 power 5, 32 variable also. We can do simply. So this is the main reason that we are using K-map. So if you watch till the end, we are going to discuss this problem using the group system by using K-maps. So how this conversion happened, that from 7 terms to the 4 terms. So stay tuned. So let's discuss the rules and all things to simplify this thing. I forgot to mention that. So how this K-map is filled with ones. So if you see that we have given the SOP format like sigma 0, 2, 5, 9, 15. So this is the same representation that you have to use. So inside the boxes we have some small purple digits, that is 0, 1, 3, 2. This is the thing that we have already discussed how to remember. So this why this has to be remember. So this is the thing that where we have to remember. So that is 0. So in the position of 0 we have to put 1. So 2, in the position of 2 we have to put 1. Likewise next one is 5. So next in the position of 5 we have to put 1. So likewise you have to fill all the positions in the places of SOP formats or the product terms. You have to fill with ones. So this is the main use of writing the numbers inside the boxes. So after writing ones inside the boxes we have to take as groups. So whether the question has mentioned in the format of SOP, the expanded thing, or the simple sigma notation, so both the representations are same. So we need to fill the K-map and we have to make groups and we have to simplify that. So let's see how to that. So these are the rules of doing a K-map groups. So the first rule is make the largest group of ones. So largest group we have to target. So ones should be covered. So there should not be at least one without grouping. So all ones has to be covered in the group, every group. So make only groups of 2 power. So we can make 2 power 0, 2 power 1, 2 power 2, means that many in the group that many elements has to be present. Like one element should be present, 2 elements, 4 elements, 8 elements. So at most these many elements can be present in that. So there should not be 3 elements grouped. So that's the main thing, remember that. So group only adjacent squares. So we cannot group them diagonally. So overlapping of groups is allowed. Okay, overlapping allowed. Corner elements are adjacent to each other. So this is the important thing that we might do mistakes in exams. So corner elements. So let's see these all examples so that you can understand these all points. So last point is make groups as minimum as possible. So if you have 5 groups, if you have 4, you can minimize to 4 groups. So take 4 groups only. So because each group is represented as one min term. So that's the important point. So let's see how you can follow these steps to make groups. So these are the simple representations. So let's see this. So if you see that I make a wrong, so you should not make a group of 6. So remember this thing. This is very important. So these 6 are, terms are at a place. So we can make a group of these 6. No, you should make only 8. So you can observe these 2 formats are also valid. So those 2 groups are not a side by side or adjacent. So we can make groups because those are known as corner groups. So the second one also, all the ones are spread across ones at the corners. So this grouping is also allowed. So we can assume these 4 ones as a single group, that as unit as 4. So this group is allowed. So how to make a group and how to make write the final output equation. So we will be going to discuss. So let's come back to the original question of that is first question. So if you observe that is expanded product term sum, that is SOP, or the sigma notation, that is both are same because you have to convert that binary to decimal and fill in the K-map in the positions where we are highlighted. So 0, 2, 5, 9, 15 we have filled with ones. So according to that we have to take groups. So if you consider the position of 0 and 2 both can be grouped. So because both are in the corners, so remaining all ones are not in the corners. So we can make group of individual because that is 2 power 0. We can make a group of 1. So we are making that 1, 1, 1 separately because all are not adjacent. Adjacent only we can make as group. So we cannot make group. So I am taking individually. So let's see how to write output of the first group. So that is highlighted in a blue color. So the output would be A bar, B bar, D bar. So if you confused how that output is came, so the output would be produced. So if you consider the row of both the elements present, that is the first row, that is A bar, B bar. So try to see all the elements to be written in the output. If any variable is changing, so don't write that. I repeat, if any variable is changing, don't write in the output form. So if you observe in the first row, so that belongs to that row. So you should write that first row should be included all, that is A bar, B bar. So if you see, consider that is C bar, D bar and C, D bar. So in that 2 expressions, the C is changing from C bar to C. So you should not consider the C. You should only write the D bar. So D bar is same. So you should write for the group that is A bar, B bar and D bar is our output for the first group. So next three also the same way we have to follow. So if you consider the black highlighted one, that one, so that is present in A bar, B bar row and C bar, D column. So likewise you can formulate the second group, that is A bar, B, C bar, D output. So if you see the next green highlighted one, that is A, B and present in the column, that is C, D. So that is output as A, B, C, D. So if you see the next purple highlighted one, that is A, B bar row and C bar, D column. So output would be A, B bar, C bar, D. So this is the output, final output equation, that is involves only 4 terms. So after adding all the group output equation, we are going to get this final output equation. So that is the thing. So if you compare the first equation after putting in K-map and acquiring the output equation, so this contains only 4 terms, but the original one contains 5 terms. Why this? So because in these K-maps we are making groups, so output equation would be definitely reduced. So we can reduce the complexity, we can reduce the cost of making the circuits. So this is the reduced one. So this is only the main use of using K-maps, to reduce larger Boolean expression into smaller expressions. Let's see an example, that is second example. So in that we have given a direct sigma notation, that is 0, 2, 5, 7, 13. So we have with this we have to understand. So this is SOP format. So we have to fill in that positions of decimal inside notations. So wherever the cell inside cell we have represented, so in the same position we have to represent ones. So in the place of 0, 2, 5, 7, 13 we have to represent all ones. So I have replaced with ones inside that. After that we need to make groups, we have to minimize that. So if you observe clearly, we have saw already the first group. So that is same as the first example, that is present in 0 and 2. So we can make that group as A bar, B bar, D bar, because the row is A bar, B bar. So in the column we are going from C bar, D bar to C, D bar, but C is changing from C bar to C. So we should consider only D bar. The output would be A bar, B bar, D bar. After that we have left with 3 terms. So with 3 terms we have to make groups like this. So the first 2 has been made with the purple color, that is one group. So next group is been made with the green color, that is another group. So you can say that 2 power 0 we can make, that is 1. So you can make the group of 1 also. Then why you are again making as combine whole thing as 2 elements? So I said as earlier only, that is the pain point in the rules also. So you should make the group as largest as possible, because if the group is largest, then you can minimize the output expression, so you can reduce the variables. So that is the use of making the group as large as possible. So here instead of making one as group, a single one, so you can take 2 at a time in a group. So if you see the group output of violet highlighted one, so that is B, C bar and D, because B, C bar would be formatted as first example only, because if you consider the rows, in the rows we are only changing B. So A is changing from A bar to A, so we should not consider A. So B variable is same, so we should consider B, and C bar D because it is in the present in the column. So that is the output, the violet highlighted group. So if you see green highlighted group, that is A bar, B, because that is present in the same row. So and D because it is going from D is same, it is going from that terms, but D is same. So that is the outputs. So add them all, that is our final output equation. So you can observe in that we have 1, 2, 3, 4, 5, because 0, 2, 5, 7, 13 we have 5 terms. It has been reduced to 4 terms itself. So let's move ahead. So in this example we are going to have the 4 ones in the K-map. So we have to fill in the position of 1, 8, 9, 10 SOP, sum of product. We have to fill once. So after filling like that, we can have like that. So grouping is very important thing in this. So you can think that one in green highlighted one is not a side, means adjacent. So why you are making a group? So you can get that doubt. So as I said, the corner things are adjacent to each other because this is gray code. So if you see the green thing that is present in the row, that is A bar, B bar, and see the last row, that is A, B bar. So if you consider, if you go from any row to any row, so that is change would be a single thing. So you are going from A bar, B bar to A, B bar. So you are only changing from A bar to A. So B bar is same. So that is known as adjacency in this. So in this K-maps you are called that is as adjacency. So all the corners would be as considered as the adjacent ones. So those two can be made as group, the green one. So you can get it out. So you can make a group of 8 and 9. So yes, we can make, but you can observe if you made 8 and 9 as a group, so that 9 and 1 again you have to make group, and 8 and 10 again has to be made group. So after doing that we have to left with 3 groups. So I as a simple point in mention also that see that at least the least number of groups has to be made. Largest group and least number of groups. This is the important point. Remember that. So that I have made groups like this. By seeing more examples, you can know how to make more groups and simple way of making groups, larger groups, smaller groups. After forming the groups, so in this we have two groups, but the expression contains four terms, means four elements. So so two groups means two output min terms. Two output min terms means in the output expression we will be going to get only the two things that is in between separated by a plus. So without doing or without adding also, without writing expressions and without adding also, simply the number of groups is equals to the number of SOP terms or the number of min terms in our final output expression. So in this we have two groups. So output expression contains two terms, two product terms. So the first blue highlighted one can be represented, that is a b bar, and so we are going from those two terms and d bar is not changing, so that is our final output, a b bar d bar. So if you consider the second group, that is green highlighted group, so we are consider first row, we have to see first row, so that is going from a bar b bar to a b bar. So if we consider b bar is not changing, so output contains b bar. So if you see the column that is contained as c bar d, so the output contains c bar d. The output equation would be b bar c bar d. So add both of them, so those are known as min terms. So two min terms will be producing as output, so that is our final output equation. So as this you can observe, 4 terms is reduced to only 2 terms. So this is the use of K-map. I hope you are understanding how to make groups, how to take the final output expression, how to write expressions by taking rows and columns. So now onwards we are going to have two problems at a time. So if you consider the fourth problem is the thing, so we have to fill 5, 7, 13, 15th positions. So after filling that, you can see like that. So it's like a thing like it is a square. So in the first one we can make a group of 4 ones at a time, because we can make in the power of 2 only. So in the first one we can make a group of 4. So if you consider the next one also, that is you have to fill in the positions of 0, 4, 12, 8, 9, 11, 10. So after filling like this, those things, those min terms, SOPs, the final expression or the output or the K-map will be looking like that. We can also groups of having 4 at a time. We can have a whole row, we can have a whole column at a time. So I am talking about this only. So I made 4 things or 4 cells at a time a group. So we can make a group of 4 cells. So if you observe the second one, so I have highlighted 2 groups, that is in green and blue. So I have also, it is a point that the overlapping is allowed. So we have to make, so we should not make 2 because where there is a scope of making 4, so make 4, make group as large as possible. So we can get 2 groups like that. After making the groups, I hope you know how to write the final output expression. So if you consider we are going from a bar b to ab in column wise. So like that you are going from a bar to b. So see that b is not changing in the changing. So you have to output expression contains b. From that we can understand. So if you go from column wise, that is going from c bar d to cd. So if you see there, d is not changing. So the final output expression would be containing b and d. So you have to consider the first rows, what rows are changing. Then after you have to consider the columns. If not changing anything, if all are present in the same row or column, you have to take whole row or whole column. So the output expression for the first thing, I hope you understood. So if you see the F2 equation, so that is the first one present in the whole column itself, the blue highlighted one. So that is c bar d bar. So that is one min term, that is one SOP. So write that is c bar d bar. So the green highlighted one is present in the whole row, that is a b bar. So that is one output expression. So write all them, add them, that becomes our F2 output expression. See that in that F2 expression in the sigma notation, so we have 0, 4, 12, 8. So we have almost 7 terms. 7 terms can be reduced to 2 terms. The 2 terms also not containing 4 variables, only 2 variables. So we can simply represent with these things. So this is the use of K-map. If you represent or if you simplify with the normal Boolean algebra, it takes much more time or complexity. Whole terms cannot be reduced easily. So see this, within seconds we are converting into a simplified expression, that 7 terms to 2 terms. Let's see another example. They have given 1, 3, 4, 6, 12, 14, 9 and 11. So according to that I have filled in the boxes itself. So if you see the second K-map, so that is given 2, 0, 8, 10. So according to that I have filled. So the second one, it's seen like corner things. So the first one sees like it's also a corner thing, but without that. So let's see how to do this grouping. As I already mentioned, if you are going from, see the first green highlighted group in the first one, that is F1 expression. So you are going from C bar D to CD, and in the down one also the same thing, you are going from C bar D to CD. So both are adjacent, so we can make a group. So I made a group of 4. So you should not make 2 as a group, because if you are, it is a possible of making 4, so you have to make 4 as a group. So the sidewise also, in the row wise also, in the row wise, the blue highlighted one, you are going from A bar B to AB. So the same row you are having 4 in the side, in a corner way. So where there is a scope of making 4, make 4. Where there is a making of scope of making 8, make 8. So that's the main motto, make group as large as possible. So that's the thing. So in the second one also, F2 expression, we are having that corner things. So corner things are also adjacent to each other, because we are only moving from, this is gray code, so those are corner adjacent only. So make group as shown there. So then you can have a doubt how to simplify this. So if you observe in the green group first, so that is going from, if you see first row, the row is A bar B bar, so going from A B bar. So if you consider B bar is not changing, so it contains B bar. So if you see column wise, that is D is not changing, so output expression would be B bar D for green group. So for blue group, the row, if you consider B is not changing, so you have to write B. So if you consider column, that is C bar D bar and C D bar, so D bar is not changing, so D bar would be output expression. If you consider, that is B bar D, so add both of them, that is becomes our final output expression for the F1 output equation. So if you consider also see that you are having many terms, almost 8 terms there, but by using K map you are going to have only 2 terms. So if you see the F2 expression, that is 0 to 8 10, so you can make group of corner things like that. So if you see the first 2, so if you consider the row, so you are going from A bar B bar to A B bar, so B bar is not changing, so B bar would be there. And if you see row wise, and sorry, just reverse them. So if you see that corner, so if you say column wise, that is D bar is not changing, so B bar D bar would be our output equation. So I hope you understood this thing. Again, let's also see this example. So they have given that SOP or min terms in the sigma notation, F1 expression and F2 expression also. So these are 8 side by side, so this is adjacency. So 8 terms are adjacent to each other, so just make as group. So this is the property, direct property. So this is not corner thing, this is just a normal group. In the second one also, F2 also, so 8 terms are side by side adjacent, so make as a group. You can observe clearly how I made as a group. 8 terms can be made as a group, so this is the group formation. So the first one, you can see all are changing A B. So first let's see A and B, but A and B's are all are changing. So let's consider C bar, that row wise is not considered. So C column wise if you consider, only 2 columns are spread across the group. So if you consider C bar is not changing, so that becomes our final output. So if you see the F2 expression, so in this also rows are not changing, means rows can be seen, but all column output are changing, so don't consider columns. So C row only. So in the row also we are only not changing with B, so the output expression would be B. So if you consider, this is big group of 8 elements. So group of 8 elements means a single output final expression, that is only C bar or B. So if you consider the previous examples, those are like elements like 4, elements like 2, so means the group of 2 elements, the group of 4 elements, those elements are becoming 3 output expressions. Like if you see the previous one, you are left with 3 output expressions. Means in a single product term we have A, B, C 3 variables. If you consider a larger group, you can have a smaller variable, like only containing 1 variable in a one product term. I hope you understood that example. So let's see another example. So in the first F1 and F2, in the F1, if you fill all with the ones, the positions of 0, 4, 12, like that, if you fill all the K map, so K map would be looking like that, the first one. The second one also, the K map would be looking like that. So let's see how to make these as groups. I already mentioned that corners can be grouped. So this is, don't make 4 because it can be grouped at a time. So 8 elements can be grouped. So we have to make 8 elements as a group, because if group is as large as possible, then we can get as minimum as possible the output expression. Means the product term will be reduced to a single output expression, that is a d bar, you can see. So because c bar d bar to c d bar, you can see that d bar is not changing, but the row wise are all changing. So don't consider the row wise, see the column wise. In the column wise also the d bar is not changing, so that is our output. So if you consider the f2, the row wise is not changing, that is b bar is not changing, so b bar is our final output for that. So you might have a question, what if only one variable or whole table is filled with ones? So let's see first case. So it might be any position. So I took an example in the 5th position, it might be in the 12th, 15th, 11th, 0, 8, in any position. So the second wheel will be in 15 positions, all the 16, 0 to 15, that is 16 positions, 16 cell K-map, all will be filled with ones. So how to solve this one? So let's see how to make a group. In the grouping property, we have that we can make a group of 1 and we can make group of 4, 8, 16, like that in the powers of 2. So we can have a group of 1. So if you consider a 1 as a single group, so that can be corresponding row wise and column wise. So that is a bar b, c bar d. See, this is a small group, very small group, so that the output expression or the product term contains the whole 4 expressions or 4 variables. So this is the main or drawback or not drawback. So if they have given a big one, so we can make as large as possible. If group is as large as possible, we can reduce whole min terms. So that's the main motto I am saying. It's not drawback. So if you consider the output expression, that is a bar b, that is row, c bar d, so that is column. So that is our output. So if you consider the whole thing, so make whole 16 as a group. So that is the property 2 power 16. You can make group of 16. So that is 1. So any of the K-map, if whole are filled, just take output as 1. So this is the example that I am saying, in that if 6 elements are given, so don't do directly 6 elements. So I am also made mistakes in that. So let's see the 9th example, that is you have to fill according to the sigma notation where we have to given. So in the f2 also. So let's see how to this group as 6 elements. So if you observe clearly, we can make a group of 4, not 6. So I made a group of 4. The first 4 elements. So again I took the 4 elements as a group. So overlapping allows, it is not a problem. So if you observe the first group, so you can see that a bar c bar, because if you consider the row wise, that is a bar is not changing, so a bar. So if you consider column wise, so c bar is not changing, so a bar c bar. So next, that is highlighted in a green box, so that is c. If you consider that is c bar d going to c d, so d is not changing, so d will be there. If you consider row wise, a bar is not changing, so a bar d. So that is final output for f1 expression. So if you consider f2, so I have filled there. So you can observe the first 4 elements can be grouped as single 4, because that is adjacency property. So the next 2, that is present in 14 and 10, so you should not make it as a group of 2, because there is a possibility of making as 4 as a group. So you can make a group of 4, because that is corner grouping. So after making, you can see for the first group adjacency box, that is a c bar. I hope you know how to write that. So the corner grouping also, that is a d bar. I hope you know how to write that, because a is not changing and d is changing, so c is not changing, so you have to write c for the first box. For the second box also you can see that. So let's also see some of the another examples also they have mentioned. So we also go somewhat hard. We can make more groups and we have to eliminate some of the groups. So let's see all these things. So if we consider, so 4, 5, 6, that group, so fill that. 4, 5, 6, 7, 9, 13, 14, 15, f2 expression, fill that also. So let's see how to group them. So let's see step by step. You can have many doubts. So why you are grouping only this? You can make group of 6 and 14, or 13 and 9, or 5 and 13. So in this f2 expression also, we can make group of 4, like 7, 6, 15, 14. We can make group of 4. Yeah, we will be going to make that as a group. I am making step by step. So this is the first step that I have made. So you can make any of the group that you use your wish, but all ones has to be covered. The group has to be larger and minimum group has to be present. So you can see that I have forwarded with another 2 groups in that. The f1 expression, that is 6 and 14 as a group, and 13 and 9 as a group. So we should not make 3 as a group, so I will not consider 5 that. So I will only consider 2 in a group. So if you consider the f2 expression, so I can make a 4 in a group, that is 7, 6, 15, 14. I can make group f4. So if you consider 13 and 9, that is blue group, that it can also be possible. So we cannot have another choices of making 4 or 8. So I have only took 2 in a group. I hope you know how to write the group expressions. So the blue group can be represented as A bar, B, C bar, and the purple box is represented as A, C bar, D, and green box is B, C, D bar. So I hope you know how to write that. So see all the variables if in a present in a horizontal way in a same row, write the whole row output expression, and a column is changing, don't consider the column changing column expression, only write the variable that is not changing. So is three variables present in the first blue box, the violet box, the purple box, the green box, any box. So if you consider the F2 expression, so if the four variables are present in a same row, the CD variables are changing. So don't consider CDs, only consider A, B, A bar, B. So that becomes our first expression, first SOP format. So if you consider the second blue box that contains A is not changing and present in the column that is C bar D. So that you can do. So the purple highlighted one that is B is not changing, and top consider column wise that is C is not changing. So that becomes output. Add them up all. That becomes the output expression. So this is another example so that you can learn further. So if you place all ones, you can have multiple groups. So in the F2 expression also, this is another example. So you can have multiple groups. So let's see how to group them. So let's see step by step. So in the first F1 expression, I am making group of 4. So you can make group of 4 in the middle also, that is 5, 7, 13 and 15. So just I am taking step by step. So you can make group of corner things first. So in the second F2 expression, I am making group of 8 because it is the largest group in this 16 cell K-map now for the current situation. So this is the step number 2, that you have to make a group of 4 in between, that is 5, 7, 13 and 15 for the F1 expression. For the F2 expression, that I am making a group of 4 for 5, 7, 13, 15 the same way, because we can because I already said we should not make group of 6 the horizontal way. So we should consider a group of 4. Other we cannot make group of 8 there, so we can make only group of 4 that is there possible. So that I am making it, this is step 2. And finally we are going to see the final output expression and the step 3. The step 3 is the final box or final group. So you can know that the biggest group or the purple group can be only of 2. So I made a group of 2 only. We cannot make group of 4, or we can make only 1. So we can have a possibility of making group of 2. So I made as group 2. We can make as single group also, single element, single group. So but if there is possibility, do that. So if you see the F2 expression, so F2 expression can also be a single element left over. So we can make a group of single element, but we should not do that. There is a making a possibility of group of 4. So we cannot make a group of 8, but we cannot do 6. So we can only do 4. So do 4 and write the output expression. I hope you know how to fill output expressions. So up to now what I have said, with that we might be confused some of the times. So this is the example. So this is not the confusion, but it has some inbuilt reductant terms. So we will not see them. We will simply write in the output expression. So let's see where we can modify the output expression. So according to 5, 7, 8, 10, 11, 12, 13, 14, 15. So I am filling the K-map of 16 cell K-map, 4 variable K-map. So it will be looking like that. So the biggest group is we can make 4s. So 2 4s are I made at least. So you can see blue group and a green group. So those are 4 elements of 4 4 in a group. Yeah, another thing that we can make 5, 7, 13, 15 as a 4 of whole as a group. 4 in a group element, 4 elements in a group. Yeah, now last, that is 12 and 8. So we should not make 2 as a group. So there we have a possibility of making as a 4 as a group, that is corner things. So that is 12, 8, 14 and 10 can be made as a group of corner. So that is not the thing that I am saying about. So see there, total we have 4 groups. So the blue group is not there at all. So let's see why it is not there. So let's see there is 4 groups can be reduced or not. So after removing the blue box, it will be looking like that. So total 3 groups are present. So that is corner grouping one thing, purple highlighted one thing, that is the group of 4, and green highlighted one is that is group of 4. So that is the main thing. We are only having 3 groups after removing the blue box also. So with this representation also we can able to cover all ones. That's the main motto. We have to cover all ones. So for that only we are making groups. So without having blue box also we can cover all ones. So why we need the blue box, the extra term why we need? So we can hold three groups. So this is the main important thing that I am saying about. So after making all the groups also, check once again that is there any reductant group, means the group is unused or all ones are covering with some groups. This group is not necessary, like that you can check and remove that groups. So that groups are known as reductant groups. So I hope you know how to get the final output expression from the groups. So if you observe, I have mentioned a question or the problem in the starting of this video. So let's see a quick overview of that problem. So if you see, it contains 7 terms. So with the help of K-map, it can be reduced to 4 terms or not. So let's check that with the help of grouping. So up to now what I have said, apply same rules and same formulas like that. So you can make groups of 2s, 4s, anything. So make group as large as possible. So corner groups are allowed, make only adjacent. So apply all the rules. So after applying, you can see the blue, dark blue one, that is corner grouping of 2 elements, green group of 2 elements, blue group of 2 elements, and 2 elements of 13 and 15 of, that is purple highlighted one. So totally we are having 4 groups. 4 groups means 4 min terms or 4 product terms. That is the final output. You know how to get the output expression from the groups. So try that. So I hope you understood all the things in the 4 variable K map. So thanks for watching up to now.